Hello everyone, let's study about compound microscope. A compound microscope consists of two lenses called as objective and then eyepiece. The objective is the lens which is facing the object and eyepiece is the lens which is towards the eye. As given in this diagram to the left side, the lens here is called as the objective. That is because this lens is facing the object. In this case, an object is a slide which contains some specimen on top of it, and the lens towards the eye is called as eyepiece. Now for our purpose, we will take a compound microscope which has only two lenses. As seen here, the eyepiece has a greater aperture than the objective. We use two lenses here because we saw that in case of a simple microscope, the magnification was not very high. That is, the magnification had a limited range. So in case if you want to magnify the objects to a greater degree, then we use two lenses. That is because whenever two lenses are used, and if the magnification of each of this is say m0 for the objective and me for the eyepiece, then the total magnification is given as the product of m0 into me. So the magnifications would multiply, hence we use two lenses. In this case, these are convex lenses. So let's draw a diagram for the compound microscope. Let's draw straight lines for the objective and then eyepiece. Suppose imagine this is the objective, that is the central line of the objective, and suppose somewhere here an object is placed. Imagine object placed in front of a convex lens. In this case is the objective. If the object is beyond the focus, then we get a inverted image which is real. To get the image, we'll draw a few light rays. So one light ray which falls like this would deviate and pass through the focus. One more light ray which passes through the optic center moves undeviated. We'll draw this light ray backwards. So the point where they meet. So the point where these light rays meet is the point where we get the image. So if the object is called as AB, we'll call this as A dash, B dash. Now these light rays would further go like this, and then if you draw an eyepiece somewhere here, this is the eyepiece. Is drawn here. Then when light falls on this eyepiece, it would refract further. So to draw the image, we'll take few light rays . So let's imagine that light ray is coming somewhere from here. So from this point, we draw them backwards. Light appears to come from this point. And also light would refract here. So light from here would refract. Draw them backwards, it appears as if light is coming from some point like this, and even this will be refracted, and then what we get would be something of this kind. This is what we get. So these light rays are diverging. So these light rays cannot meet on this side because they're diverging. So if we draw them backwards, these appear to come from a point. So this point is where we get an image. We'll call this as A double dash B double dash. Now let's finish the lenses. So this would be the objective, and this is the eyepiece. Draw it properly. This would be the eyepiece. So here we get the image. Now let the focal length of the objective be f0 and the focal length of the eyepiece be f suffix e. Now distance between the optic center of the objective to this point B is called as u0, because the distance would be u0, and this point where image is obtained, this point would be called as v0. Now for the eyepiece, this image formed acts like an object. So distance between this to this would be called as ue, because for the eyepiece this a dash b dash acts like the object, and finally the distance between this optic center of the eyepiece to this point is called as ve. Now the range of ve would be between d to infinity. Now keep in mind here that for the eyepiece, the image is formed on the same side of the object. That means that this a dash b dash is formed within the focus of the eyepiece. The range of ve could be between d to infinity. So this is what is a diagram for a compound microscope. Keep in mind that it is easier to draw using straight lines than using the lenses first. So practice it, make a habit of drawing the straight lines first, then draw the lenses. Now let's find its magnification. Now in this case, the magnification would be because of the objective and the eyepiece. The objective behaves like a simple microscope. It behaves like a normal lens for which m is given by minus of v by u. Since it's the objective, it becomes v0 suffix u0, and me is like a simple microscope, and we learn that for simple microscope the magnification is given as d by 1 by fe plus 1 by ve. To understand this, go back and look at the simple microscope topic. There for total microscope, the total magnification in this case is given as m is equal to, it would be minus of v0 by u0 d by fe plus d by ve. Now again here we can get two cases where case 1, image is formed at D. That would mean that VE is equal to D. Then what we get is M suffix D is equal to minus of V0 by U0 D by FE plus 1. Now, similarly, if you find a case 2 where image is formed at infinity, that would mean that VE tends to infinity. Therefore, the magnification in that case will be minus of V0 by U0 D by FE, and it becomes plus D by infinity, which becomes basically 1. So this is the magnification in case of image formed at infinity. Keep in mind that MD and M infinite are the extreme limits of the magnification. In most cases, it will be somewhere between these two only. Now observe that the magnification is a minus sign as given here. Unlike a simple microscope, it was positive. Here it is negative. That is because if you look at the image, this image is inverted. That is A double dash B double dash is a final image. This image is inverted with respect to the object. Hence it is negative. And one more point here is the distance between the two lenses is called as length of the tube, given by capital L. So capital L is called as length of the tube. It is called as length of the tube, which basically means it is distance between the two lenses. And from here we can find that L is equal to, it will be the distance from here to here. We can divide that as distance from here to here plus this distance. So it becomes V0 plus UE. But then here we want only the length, not with sign conventions. So we take its magnitudes. So this is called as length of the tube. In a similar way, you all can try as an exercise and see and find out what is length of the tube when the image is formed at D, and also to find length of the tube when image is formed at infinity. So this is about a compound microscope.